So hello everyone, I am Anmol Kapoor and I have been allotted lecture number 11 as video assignment. Lecture 11 covers basics of Poisson random variable, and we are going to first see little bit theory about the topic and then do the question related to it. So what is Poisson random variable? It's basically an approximation by which we can calculate probability of a given distribution, and in this case probability mass function is given to be e की power minus lambda into lambda power I upon I factorial. Also, we have to have lambda to be a constant value. Moreover, lambda is the expected value or the variance of a probability distribution. The proof can be seen in Ross' book. For lambda to be a constant value, n into p is basically lambda. So for lambda to be constant, n, if n is tending towards infinity, then p should tend towards 0. We are going to use this theory for the question on next slide. So the question is that we are having 1 nanogram of plutonium-239, which is a radioactive material, and it has 6.9 radioactive decays in 3 seconds. Also, it is given to us that it follows Poisson distribution. So we should first justify that whether this Poisson distribution is okay for this case or not. So I'm going to give a feel about that why Poisson distribution should work here. So we know that 1 gram is equal to 16 to 10 to the power 23 atoms, and we are given 1 nanogram, which is having approximately 10 to the power 14 atoms, which is very large. So therefore n becomes very large, and consequently p becomes very small, and therefore lambda comes out to be a some finite value. So Poisson can be applied in this case. Also, we are given that it is having 6.9 radioactive decays in 3 seconds, and we are asked the probability that in 1 second period there is exactly x radioactive decays, and we have to plot it also. Now, seeing this formula, we can say that putting the value of small x in place of small I, we can have our required function, but we need lambda. As stated on this slide, lambda is equal to the expected value of the distribution or variance. Here, it is given to us that 6.9 radioactive decays happened in 3 seconds. So in layman language, 2.3 radioactive decays, that is 6.9 upon 3, happened in 1 second, and that is the expected value. So lambda comes out to be 2.3 decays. Now putting out this lambda in this equation, we got this as our final function. Now putting values of 0, 1, 2, 3, 4 and so on in place of x, we got this as our function. You can see that as x increases, probability decreases to 0. In fact, at values greater than 6, it is very much closer to 0. We are also asked to calculate probability of having radioactive decay greater than or equal to 6. We know that probability of x is equal to 1 minus probability of x complement. So required probability is 1 minus decay, probability of having decay less than 6. Probability of having decay less than 6 basically means it is equal to 1 minus p0 plus p1 plus p2 up to so on till p5. Also, putting the values of these P0, P1, P2, P3, P4 and P5 from the graph, we got the probability is equal to 1 minus 0.965 or 0.035, which is very much close to 0 and can be taken approximately 0. So probability for values greater than 6 is very low and it decreases further. Therefore, we can say that probability at higher values is very low. We are having a maximum at around 2. Last part of this question was that what would happen if we would have doubled the period of observation. Period of observation basically is 1 second in the previous case. So if we would have doubled the case of period of observation, we would have 2 seconds instead of 1 second. So in 2 seconds, the expected value would not be 2.3. It would have been instead it would be 2.3 into 2, that is equal to 4.6 decays. Now putting in the formula, we got e की power minus 4.6 into 4.6 की power x upon x factorial, which is equal to e की power minus 2.3 into 2 power x and times the probability for 1 second. So we got that the ratio of probability for 2 second and 1 second observation period is dependent on x and is proportional to 2 की power x into some constant. Thank you. अच्छा गया बट ये मतलब ये थोड़ा सा मैं नहीं करूँगा अभी, रुक जाओ।